one thing I should say, you bought a car, you just got it home, you're going through it, chances are the needle that's in the car is the right needle. But every once in a while, if you really dig deep enough, you'll find out it's got the wrong needle in it. You know, most people don't go in that far when they own a car, but if you got a guy that really got his hands in there that shouldn't have, he's got the wrong needle in there, you could drive yourself crazy why this thing doesn't run right. So sometimes you have to go so far as to look into what needle you have. Now, on the side of this damper is a small hole with a set screw. You loosen that set screw and the needle should pull out. There are two kinds of needles. This one's a fixed needle. Once it's in, it's in. There's no movement, there's no play. The later carburetors have a spring-loaded needle, and it allows for some movement. Exactly why that is, I honestly can't tell you, but those are a lot easier to work with because you don't have to center them when you're putting them in. So the needles have, this is a book on tuning SU carburetors. I've had it for years. I'm not sure it's still available. I'm sure it probably is. But right here kind of explains it to you. You've got a needle that maybe is 2 inches tall, let's just say, and what they do is they take measurements, you know, every quarter of an inch or every eighth of an inch. They measure the diameter. So just to exaggerate, you know, you'll have, look at this. This is pretty cool, huh? This is new. Yeah, this is great. So, you know, an exploded view of the needle would be this. This is the part you don't see. This is in the piston itself. You just see this. So some of them might look like this, and some of them might look, you know, more like this. Okay? And it all depends on how the car, you know, what the tuning requirements are for the car. Now, this one would be very rich at idle, and this one would be very lean at idle. Because actually, this one is much.
It's the other way around, actually.
Other way around.
It'd be very rich at full throttle.
I'm sorry. You're right. I'm sorry.
Sorry.
Absolutely right. Yeah, that's right. Because when it's at idle, the piston is all the way down. So what it does is it dictates how much fuel is getting into the carburetor at various levels of acceleration. So again, this is not happening very often because most of the time people don't mess with the needles. But you get a car that's great, it idles nice, it has nice acceleration, and you get up at the higher end of the limits, and it just doesn't feel like it's getting enough fuel. It could be a number of things, but one of the things it could be is it could have the wrong needle in it. And when you find that out, you're happy because that's a simple fix. You just buy the right needle. You call up Joe Curto and you tell him what you have. You got a 72 MGB. I need the right needle for it, and he sends you the right needle. You put it in, and you're done. So there are hundreds of different variations, and sometimes you can make your own determination as to what you might need. If you have a book like this, or again, I'm sure this stuff is online. In the back of this book is page after page of these charts. And for example, you know, you take your needle out, and written right up here on the side of the needle. You need your magnifying glass. Is what it would be, an AE needle or a number 6 or whatever it says on there. And there's countless dimensions here. So here's a BBU needle just for random sake, and there's 16 measurements that they've taken on that needle, and it tells you what the measurement is at each of those levels. And if you feel that you need a needle that's a lot like the one you have, but you need it to be a little richer on one end rather than the other, you can kind of look at the accompanying chart and figure out, well, I think I'm going to go to a BBW. You know, that looks like it might help me. So you buy 2 needles and you throw those in. This is all pretty advanced stuff. As I said, chances are you're not going to have to deal with that, but I wanted you to understand what that needle is, why it's important, and what it does. Along with the damper. I got a question earlier from a fellow that was telling me that when he first goes to start his car, the pistons, they won't go up and down. They're stuck. He gets out there and he pops them free, and then everything's fine. So he wanted to know what I thought it was, and what I think it is that he's got varnish on either the needle or on the outside surface of this piston, or, you know, he's got varnish somewhere, and the varnish comes from old gasoline, and the gasoline doesn't last nearly as long as it used to. And when it goes bad, it just turns to varnish. It's amazing what it does. So the solution there is to just take the top of the carburetor off and take out the piston and clean everything out. Just clean, everything should be clean. No gunk, no varnish, no nothing, particularly the needle itself. You want to make sure the inside surface of this is clean and smooth. Carb cleaner, lacquer thinner, you know, I mean, as long as it's working, you know, you'll see that it's taking it off. Clean the inside of this, and you might have to go so far as to spray down into the orifice in the jet and clean the varnish that might be causing it to stick in there, or get a new jet. It might be time for a new jet. They're not expensive. But it's important that this piston, when everything's working right, is free to go. It's free to move up and down. You should be able to reach in there and pull it up with your finger easily, and you should hear that clunk. If you don't hear that clunk, it's not dropping freely, and if it's not dropping freely, it could be hanging up ever so slightly, which means that you've got an idle on that carburetor that you're never going to be able to get down to where it should be, because it's just allowing that much air to get through and raising your idle. So it should drop, and you should hear that, and that's something that you need to do when you're rebuilding your carburetors. Is make sure. That's probably the hardest part, to be honest with you, when you're rebuilding a set of carbs, is to get that needle centered enough so that it drops down in. It'll drop down nice right now, but then when I put the spring on here and I lock everything in place and create a much tighter tolerance with this, you think you're going along great, you tighten everything back up, and you try it again, and all of a sudden it's locked up solid. Well, that's because you didn't center the jet when you put it in.
I have a question
Yes.
about varnish. Does that form even though everything is fully loaded with gas, or does it only form when the gas evaporates from the carburetor?
I think both, but I think the varnish is more apt to accumulate on those surfaces that had fuel on them, and now it's just a film. You know, it was a film of fuel. You know, you haven't run the car in a while. So, you know, there's residue of fuel on here, or in here, and that's what's turning to varnish.
So when the fuel vaporizes or
Yeah.
evaporates?
Correct. I mean, we've had a case, it was so bad that the intake valves had varnish on them, and they were getting stuck. This was an old MGTA, which had real weak push rods, and we bent the push rods because they just couldn't push up these varnished, the valves. So it can get so bad as to become a problem inside the head.
So it's probably a residue from the evaporation of the gas.
That's my thinking.
Okay.
Yeah.
No, it's basically caused by electrolysis, the warming and cooling of the metal creates the varnish.
Okay.
That's-
On the residue that's on there?
Even full gasoline will still do it.
Yeah. Yeah, I mean, the full gasoline is going to turn to varnish. I mean, we got a car in here that's been sitting for 5-10 years, and you drain that tank, you're draining out. I mean, it's varnish. You could strip paint with it. So he's right. But generally, if you can drain the tank, flush the lines, and then clean the carburetor, you can generally get away with starting fresh. You know, fresh fuel, and then you're back on track. You're back on track.
Thank you.
Yeah.
Pete,
Yeah.
just remind people, if they're going to go in and try to clean out the inside of that bell chamber or the needle or the piston assembly, to not use steel wool,
Right.
emery paper, anything that's abrasive, because actually that tolerance between the piston and that bell on the carburetor is extremely precise. And in driving the car, you're actually pulling air past that as you're making the suction. So over time, even dirt in the air that gets past the air cleaners can wear away at that. We've seen problems where the piston just doesn't respond properly
Right.
because it's the wear between the piston and the bell chamber has gotten excessive.
Right.
So if you think you're going to clean it up, oh, they'll steel will polish that needle
Yeah.
up just right. Not a good idea. Just a solvent
Yeah,
only.
and what he's talking about are the tolerances that are around this slide right here. They are critical. You know, John Twist, the MG guru from Michigan, he does videos, and he discusses that, and discusses, you know, if you think about it, you got 40-year-old carburetors, how many times they've gone up and down over the years, and how much potential wear there is on these surfaces. He's right, and you're absolutely correct. I can't say that I've run into too many problems with, I don't think I've ever had to replace a damper or a piston because I felt that the wear was excessive, but it definitely is something you don't want to get too crazy with. Just some solvent, just clean it up solvent-wise. I'm going to jump around here a little bit, but I talked about centering this the jet. Unfortunately, I don't really have the right. Okay, I'll use this set right here. Okay. So we have the jet here, which is this brass tube, and it goes into what they call the jet bearing. This is a series of tubes and springs and nuts, and you would get that if you buy them to rebuild the carburetor. And when you put these in, they just simply screw into the bottom of this carburetor. There's threads there, and it just screws right in. It seems awfully simple. Put it together in the right sequence, put it in there, and then this slides in there, and you think you're good to go. But what happens is that it's slightly off centered, and if it's slightly off centered, that's going to prevent this needle from dropping down and giving you that proper clump. So
Did you turn that this way?
I'm sorry. So you've got this hole, you got this. This needs to be centered in that orifice through the jet bearing, which I don't have here. I'm sorry. So the way to do that is, and Bruce worked on rebuilding those Zenith Strombergs over there on the bench, and Bruce learned firsthand the frustrations of trying to get these things to center. It's very much a trial and error situation, but what you would do is you put this together without the piston. So there's no piston in it. You're just going to put the top on, and then you buy this jet centering tool from Moss, and this drops down, and it goes all the way down in. And what it's doing is it's giving you a peg that's going to protrude, so that when you put that jet bearing in and you screw it in, it's centering it. It's 90% effective.
That's cheating.
It's 90% effective. I wish it were more effective, but it can still give you a lot of trial and error. And that's what I talked about earlier. On the later carbs, they have a spring-loaded needle. This needle is affixed to the piston, but it's like it's floating. You don't have to worry about that because it kind of takes care of itself. I mean, I still subject you use this, but it's not as much of an issue.
Pete, would you use that on Strombergs too, the centering tool?
No. I don't believe so.
Okay.
I don't believe so. So now we've got the fuel. It's coming up through the bottom, right where it belongs. It's getting past this needle. It's entering the carburetor, and you're driving down the road and you're having a good time. So what could possibly go wrong with these? What are the common problems with SUs? Guy brings his car in, it's not running right, it stumbles, it hesitates, it won't idle, various things. I'll do what I call a carb service. First thing I'll do is I'll do a carb service rather than a rebuild. A carb service, I take the air filters off, take the tops of the carburetors off, and get it down while it's still on the car to its barest essential, so I can examine it. And I'm going to look and I'm going to see how dirty things are, see if there's varnish in there, make sure that I'll go so far as to take the needle out and make sure it's the right needle for the car. Make sure you got the same needles. Believe it or not, sometimes, again, they get in the wrong hands, or a guy just grabs another piston from another car, throws it in, and one's got one needle in it, the other one's got the other needle in it. So I do a full thorough cleaning, take the top of the float bowl off, and clean in there. Always needs to be clean in there. It seems no matter how many times you clean it, it needs to be cleaned in there, because there are two little cavities on either side here that just seem to collect sediment. It's probably good that there are little cavities to collect the sediment. That keeps it from getting into the system. But nevertheless, I'll get in there with a screwdriver or something, and I'll stir it up so that it joins the fluid that's left in there, and then I'll use a little sucker and I'll suck it out and spray it, clean it, clean the jet, again with some carb cleaner, and then just put everything back together, and then I start the tuning process. So what could be wrong is that you have more than one carburetor. Each carburetor has its own idle adjusting screw. You could have one that's idled at 1200 and the other one's idling at 800, and that's a problem. It's not very smooth, it's not very even. So you want to synchronize those, and I'll discuss that. You could have a high idle. The high idle is adjusted either too high and it races, or it may not be adjusted at all. So when you pull out that choke to get your high idle, you don't get anything. You got nothing. And then of course the mixture could be off. Those are some of the adjustments that could be wrong. The potential problems I've already discussed. You could have the leaking jet from here. Misadjusted linkage. Okay, these linkage pieces join the two carburetors together. And generally, you'll have an accelerator cable that'll come and it'll operate one lever that's attached to that piece of linkage, attached to a rod, and then attached to the second piece of linkage on the other carburetor. And if they're misadjusted, when this one starts to move, this one may not start moving for another split second, another tiny bit. And that's you want them to be in complete synchronization. When this one starts to move, this one has to start to move. Same thing with the choke cable. And how you adjust that is on the linkage pieces themselves. There are two nuts. You loosen those nuts, and then these levers are free to turn. So you want to loosen those and operate the cable, and make sure that when the one on the right starts to move the carburetor linkage, that the one on the left does the same thing. And you compensate by just adjusting these knobs ever so slightly, so that when you pull on the cable, it's moving them both at the exact same time. Because no matter how many times you synchronize the idle with our fancy little unison, you're going to throw it off because they're not operating at the same time. Again, sticking needle and seat, which we talked about. This could be dirty and you're getting overflow, or the jets are leaking. So those are the potential problems. When it comes time to, I've cleaned it, I've gone over everything, I've put it all back together. Now it's time to tune it. You want to start the car, have it at idle, have it warmed up, and you want to disconnect that linkage piece that I was just talking about, so that each carburetor is independent of one another. And you're working on one carburetor at a time. And it's idling, and you use one of these unisons. There's a couple of different tools on the market, and then there's the old-fashioned way of taking a tube and putting it in your ear. You see the diagram in the workshop manual, and the guy's got it, and he's got it right up next to the opening of the carburetor, and it's actually pretty effective, but so is this. So what this does is you put this flat up against the throat of the carburetor, nice and tight, and it's got a foam seal here, and it's measuring the air that's going through the throat of the carburetor. Okay, it's measuring the air that's going through, and what it's doing is it'll cause this little bubble, this little red ball to rise. Now the point is it doesn't matter where it rises to. You can adjust. There's a little adjustment thing in the middle here that can make it rise higher or make it drop down. The point is, find a spot on there that you like, and then make sure that it's doing the same thing on the other carburetor. That's the issue with this. So nice and firm up against here, and then up against the other one, and find out how far off they are. Again, they're separated now because you've separated the linkage. Want to adjust each of the throttle idle screws to give you the maximum idle, and as I said, 1,000, give or take, 100 or 2. Once they match, you're set. They're synchronized. Now you want to reattach retighten those linkage pieces, and this is where again you have to be careful that you retighten them so that again when you're operating them, they're operating those carburetors at the same time. What if you can't get one to idle down far enough? No matter what you do, it's racing. You can't get it to come down. you got a vacuum leak, you got a problem. Oftentimes, when somebody rebuilds a set of carbs, okay, here we go. We got, all right, you got the dreaded throttle shafts. I haven't really even touched about the throttle shafts. You got the throttle shaft that goes through the throat of the carburetor, and that that opens the valve, opens and closes the valve. I'm going to go back several steps. This is another potential problem. These wear out. They're in here and they're rotating, you know, thousands and thousands of times over the years, and the brass gets worn out on the two edges where it goes through the body of the carburetor, and it allows air to enter through here, right through the edges. And how do you find out it's leaking through the edges? You take some carburetor spray cleaner while it's sitting there idling, and you point it towards those two joints. And if the idle reacts significantly, then you know you've got an air leak there, and that means that you need new throttle shaft and potentially new bushings if they're really bad. There are little brass bushings inside there. That's something that you can do at home if you want. You need to buy the reamer, you need to buy the bushings, and you kind of need to know what you're doing. Or you can send them off to somebody, and I don't. Just having them rebushed is a lot less than having the whole carburetor rebuilt. Or you can buy oversized throttle shafts. Moss sells oversized throttle shafts, so it would be the next size, bigger, which means you don't have to worry about the bushings, but you need to have the special reamer. It's more than just a drill, you know, that you go in there and drill, because it has to be completely line bored. It has to be perfectly lined up. So it's a little tricky for the average guy to do, but if you have the tools, or you have access to the tools, it can be done at home. What does the leaking throttle shaft do? Honestly, it causes a rough and an uneven idle. It generally doesn't affect the performance of the carburetor once you're actually driving. You've created enough vacuum by just driving along that most of the vacuum is coming through the throat where it's supposed to. But at idle, you're only supposed to have a certain amount of air coming through here. And that air is mixing with the fuel that's here. So if you've got air leaking back here into the system, you've got way too much air coming in that hasn't been mixing with the fuel. So it's going to create a rather lean mixture at idle, and an uneven mixture, an uneven idle, because sometimes it's sucking air and sometimes it isn't. I mean, it just shouldn't be sucking any air. But I think even on a perfect set of carbs, you spray some carb cleaner right at those, you're still going to get a little bit of a reaction, so don't freak out. You know, don't everybody go home and try this. Have a line out the door, people wanting me to re-put needles. You're going to get a little reaction, but you know, if it's a significant, I mean, the thing stalls on you, you got a problem. Okay.
Would that shaft come in a carb rebuild kit normally, or would that wouldn't be part of it?
Depends on there's varying degrees of carb rebuild kits. You know, there's a major kit and then there's a minor kit. I'm not sure 100%, but they're listed on the same page, and it tells you on that page what's included in a carb rebuild kit. So, all right, I forgot where I was. Okay, so we're synchronizing the idle. We're using our trusty unison. The idle is perfect now. Each of them is at 900, steady as a rock, beautiful. We like that. Now we're going to adjust the high idle. So we're going to operate the choke, and you'll have to study. You can come over here later and study how this works exactly, but by pulling up on the choke, it turns a lever, and there's a second screw that will open up the throttle ever so slightly, and that's what gives you that high idle. So you want to adjust that screw to specifications that are in the book, or to an idle of maybe 1200 or 1500, something along those lines, whatever you feel comfortable with. You want to have a little bit of a high idle. And then the third adjustment is the mixture adjustment. And there's two different styles of carbs here, so there's two different ways of adjusting the mixture. The mixture, of course, is dictating how much fuel is mixing with the air that's going in. On the HIF carburetor, oh, by the way, I can take the bottom of this HIF carburetor off just to kind of show you a slight variation between this and the HS. Okay, so in here is, you know, a reservoir where fuel will be stored, and there's the float, similar concept as that. And then this little periscope tube here is where the fuel comes up and goes straight up into the carburetor. So that's your jet, that's your float, and the fuel is being stored in here. Now, on an HIF, there's a mixture screw on the side, and by turning it, let's see, by turning it in, what I'm doing is, let's see if I can draw this out. The jet sits in the carburetor like this, and there's a screw coming in from the side here, and there's a, you know, there's a levering system. So as I screw this in, it's raising it up, or vice versa. I'm not certain right at the moment. And as I unscrew it, it's pulling that jet down, and that's how you adjust the mixture. What am I adjusting when I adjust the mixture? Is I'm adjusting the level of that jet that we talked about earlier. I'm adjusting the level of where this is in relationship to the bridge of the carburetor. The bridge is this flat section right in the opening. And when you adjust the mixture, you're adjusting just how far up or down this jet sits, and is where it stands as far as feeding fuel into the car. So on an HIF, you've got the screw that's on the side. On a Healy, there's a screw on the side of the carburetor. It's a horizontal screw, and it works a series of levers and raises up the jet or lowers the jet. It's much easier to visualize on an HS carburetor. Okay, there's two nuts here. If you can see, two brass nuts. The top one is holding this assembly to the carburetor. The bottom one is free to turn. I can turn it with my fingers. I can turn it out, or I can turn it in. The jet is right here, so if I turn it out, I'm pulling the jet away from the bridge of the carburetor. And if I turn it in, I'm pushing that jet up closer to the bridge of the carburetor. It's nice and simple. When you're done adjusting, a good starting point is screw them all the way up till they're tight, and then back them off. They talk about flats. The term flats, you know, that's a flat. A flat is the side of the nut. So I think it's 8 flats, or just 2 full turns. 2 full turns down. That's an excellent starting point, and should get you pretty close to being able to get in the car, start it, and have a fairly decent running car. And then some minor adjustments from there. Take it out on the road, you know, see how it feels. Check your tailpipe, check your car, you know, plugs, various things. I mean, it's a trial and error thing, but two full turns down will get you started. And actually, I believe it's somewhat similar on the HIFs. You know, screw it all the way in, and then out 2 full turns. And that will adjust the mixture. So, if you've done all these things, you know, the big complaint over the years is, those SU carburetors, you're constantly going out of sync. They're going out of, you know, they're going out of tune. I don't know how that's possible. I mean, I don't know how they can go out of tune and out of sync unless you've gone out there in the middle of the night while you were sleepwalking and turned some screws. You know, it's all mechanical. Either the screws have turned or they haven't turned. So that goes back to the fact that they're much maligned and they get a bad rap. Once you set them and you understand them and you know how to work on them, you set them, and you know, it's like that oven that the guy sells on TV. You set it, forget it. You leave it alone. Yeah, oil in the damper. Good question. Oil in the damper. Okay, so there they are. They're sitting on your car. You're poking around. You're checking your oil, and you're doing all sorts of things. And you unscrew these little caps, and the manual tells you to put oil in there. So what you want to do is you want to get a little a little thing of oil.
What kind of oil do we
Well,
put in there?
very good question. That and ZDDP and tire age, questions that'll never be answered. There's an opinion about it. Everybody's got a different opinion. My answer to what kind of oil has always been, if you put oil in there, you're doing better than 75% of the people that own these cars. Put Wesson oil in there, because most people aren't putting it in there. But Moss sells the little bottles at various vendors. I push Moss because it's one word, it's easy to say. Victoria British. But, some dash pot oil. And you want to put it in there until it's about an inch from the top. The other thing I tell customers is that this isn't rocket science. If it's not exactly an inch, it's not a big deal. If you forget about it, it's not a big deal. It's a minor. It has a very minor effect on the performance of the carburetor, and I'll explain how it does that. So, what type of oil? There's special carb oil. John Twist is now on the YouTube telling everybody that you should use gear oil, which is really thick. Other guys are using Marlboro Mystery Oil, which is really thin. And again, I don't care. Just put some oil in.
I use ATF.
ATF is a lot like Marlboro Mystery Oil. It's thin. Honestly, I think it's all good as long as you're putting something in there. Now, what is the oil doing?
Engine oil?
Engine oil's good. Yeah, leftover engine oil. You're done with that quart, you're just changing your oil. Throw it in. What is the damper doing? Go ahead.
One thing you might want to bear in mind is the thinner the oil, the faster that piston comes up, and you want the piston to stay down because that's what gives you the equivalent of a pump jet, like on the Weber.
Right.
The fact that the piston doesn't go all the way up as soon as you mash your foot to the floor.
Exactly.
So I've always used motor oil. Like if it's a Mini 2050,
Yeah, and that's what I'm gonna get into. What are you doing? What are you doing with that oil? Why are you putting it in there? Well, as you accelerate, as we talked about before, this piston is going up. The faster you accelerate, the faster this thing is raising up. And what's stopping it from raising up too fast is the fact that you're putting oil in there, and then with this little cap, it creates kind of like a shock absorber. It's creating some resistance. That oil in there is stopping it from shooting up, violently and too quickly. And what happens if it goes up too quickly is that you bog down. You're just pouring too much fuel in there. Because again, now you got to remember, we're talking about the precision of this tapered needle. You want to be able to use that precision to the way it was designed. It should be going up at a nice steady pace and coming down at a nice steady pace. So that's what the oil in there is doing. And you could drive yourself crazy trying to keep it full, because no matter how many times you put oil in there, it always needs more oil. But try to make a habit of it. Go out there and polish your tires and put some oil in there.
Pete, I had my rear carb, the cap kept popping off till I took the washer off and screwed it down. Now it doesn't do it.
The washer being the seal, there's a sealing washer.
Right.
Yeah.
So I took one of those off and screwed it down. Now it doesn't pop off.
Yeah, and we've come across
Is that
that.
wear on the cap or
I'm sorry.
wear on the threads of the cap or what?
It just could be worn threads on the cap. I mean, I think if you bought a new cap, it'd probably solve that. But that washer he's talking about is just a sealing. It's a sealing washer. In fact, this is missing to stop oil from coming out the sides. But before it comes out the sides, it's going to come through that little vent hole anyway. Oftentimes, you'll see little traces of oil on the underside of your bonnet after you've filled it, because it squirts up and creates a little bit of a mess. But just putting oil in there is a good thing. It's going to prevent it. Recently, I actually had a car in here that was exhibiting some kind of funky acceleration, and I came back and I added oil to it, and it went away. I mean, and I can honestly say that was one of the few times that's all I had to do was just come back and put some oil in there, and the acceleration was much smoother and much more responsive. So it's a minor little difference in your carburetor functioning, but it's part of the whole process. And if everything's working the way it should, they really give good service. They're simple. Well, they're simple. I just talked about them for an hour and a half. They are simple because there's very little moving. There's very little movement going on, and if you understand how it's getting to the engine through that carburetor, and hopefully I've done that today, you know, giving you just some idea of what some of the trouble spots are and what these things are doing. Why is there a float bowl? Why is the needle going up and down? I mean, hopefully you can have a better understanding of what it's busy doing, and you won't be out there at the cruise night, you know, bashing your SU cars. Let's stick up for SU cars. They're good. They're British. They belong on the car. And ignore that Weber sign up there. That's just decoration.
Good too.
I don't have any SU signs. Joe Curto's got all of them.
They're okay
Yeah.
too.
Now Webers are fine. I'm not putting them down. I'm just explaining to you why, you know, why they're different and why there are so many of them. It's just as simple. You pick them up, pick up a catalog, buy a brand new Weber. It's brand new. It's fantastic. You can put it on in a half hour and drive away, and you're done. If you want to deal with your broken down SUs, it's a little bit more of a problem. I mean, you know, it's a little bit more involved. There's rebuilding, there's rebushing and tuning and setting. So it takes a little bit more work, but in the end, it gives you a better experience.
Weber's running rich, you can't tune it out unless you have the jet.
Correct. Yeah, the Webers use various small jets and orifices, little brass, and you got to have a selection of those if you want to do any tuning. So I hope I've given you something to go with. Okay, if you're accelerating and it's coughing, it's spitting out the carbs, oftentimes I find that's a timing issue. It's just not time, the timing's off. Or it could be too lean. But most of the time that's a symptom of something else rather than an issue with the carb. Yeah.